My name is Faraz Hedayati and I'm a lead research engineer at IBHS. Heat release rate is the most important parameter in fire science. It basically tells us how much energy is released and how much of that energy can go into different areas. For example, in the wildfire context, we have a fire and then we can measure the heat flux at different locations around it. This tells us what is the intensity of the fire when it burns. We specifically bought this to study roof shingles, like asphalt shingles for roofing, but it has numerous applications in different aspects of our research.
Hi, my name is Dory Sinolis and I'm the Cone Calorimeter lab technician at IBHS. So this is the analytical piece of the Cone Calorimeter that we just got at IBHS. We're able to manipulate the amount of heat that's introduced to the surface of each sample. By doing this, we're able to determine the heat flux, the heat release rate, and the flammability of each building sample that we are testing on.
So the mass loss platform that we use for the shed burns is designed for large fire. This is designed for small fires and is more accurate, more sensitive. It has two ways to measure it. One is at the bottom, there is a mass loss platform and it can also analyze the smoke above it and we can compare the two. We can use it for many projects. For example, for asphalt shingles and the effects of aging on that, we can test new samples versus aged samples and see how the fire characteristic changes with time. We can also use it for siding material, we can use it for ornamental vegetation, and many other projects.
Well, I'm very excited. As you heard from Faraz, we have a lot of cool projects coming through the pipeline, and we're going to be able to really grow our knowledge about wildfire here at the research facility. So I do know that we're going to start out with plywood testing to create a good baseline for our building materials here, and then we will move on to asphalt shingles. And they are very diverse and they can create a lot of inconsistent results. So I do believe that we'll get a lot of information from our various test specimens.
This device is designed, is the benchmark scale to study fires. And nearly all major fire labs do have this, and we have been using this in a different way. We have been contracting this out. So now that we have the capability, we can scale up, we can run more tests, and we can look at the fire performance of different materials. We have an aging farm out there, and we have a lot of samples to test.